this video, we will finally put the ESP into good use. We will use it to drive the servos to open and close the face shield of my Ironman mask, and we'll also use it to turn on LEDs that will light up his eyes. In this video, I will not go into the details of ESPHome, how to flash the microprocessor or anything of these basic things. If you're new to the topic, please look at my previous videos where I did a in-depth step-by-step walkthrough. For the Ironman mask or the shield, we need two servos powering the up and down motion of the faceplate and an LED or two to light up the eyes. And as you can see from the image, I connected my two servos to the D1 and D3 pins of my Wemos D1 Mini, and the LED is connected to D5. So that's more or less all the wiring that is needed for the task at hand. The more activities we want our ESP to drive, the longer the source code gets and the more items we have in our source code. So let's take the time now and go through the elements here again step by step. We start with the global identifiers for the project. The variables name and friendly name are defined as substitutions to keep the configuration modular and easy to update. These will name our device Ironman Helmet. The ESP8266 section specifies the microcontroller board, here set to D1 Mini. This board is compact, cost-efficient, and ideal for projects like this one. Logging is enabled to help with debugging, while the Home Assistant API, which is commented out, would allow seamless integration with your smart home setup. Over-the-air updates are configured to make future modifications hassle-free. Wi-Fi provisioning uses secrets for your SSID and the password of the network that your ESP connects to. This keeps your credentials safe and reusable. Next, we define hardware outputs. Two PWM outputs control the servos on pins D1 and D3. While a GPIO output on pin D5 is configured to manage the helmet's eye lights. This output is then linked to a binary light component named eye. Two servo motors control the helmet's motion. The configuration includes an auto detach time to save power and reduce wear, and a transition length to define the servo speed, in this case full speed. Template buttons named Open Helmet and Close Helmet provide user-friendly controls. Each button triggers a corresponding script when pressed. The magic happens in these scripts. The Open Helmet script writes servo positions to open the helmet and turn off the eye lights. Conversely, the Close Helmet script adjusts servo positions to close the helmet and turn on the lights. This logic ensures synchronized movement and light effects. And it's really important to note that the levels that are set here in the script is something that you will have to fine-tune by just running it and using the good old trial and error method. The captive portal feature makes Wi-Fi provisioning straightforward, while the web server provides the user-friendly interface for control and monitoring. For advanced users, dashboard import allows seamless integration with other ESPHome configurations. And that's the complete walkthrough. I hope you liked the video and that it was useful and educative for you. If it did, please leave a like and maybe even a subscribe.